Hello and welcome to the final presentation for the forecasting budget team for the intake number 14, summer 25-26. This was a brand new project, and the fact that, and I'm trying not to steal your thunder here, that a really positive result came out of this is amazing to say the least. So without further ado, I'm going to hand over to Ben Howe. Ben Howe, please take us away.
Okay, hi everyone. So my name is Ben Hao, and today I'm joined by my teammates, so Minghui, Nairaline, Ken, and also Vedenti. We are very excited to share the outcomes of our WeHi Summer internship on this forecasting budget project. We believe it is a wonderful prototype, and we hope you will enjoy it too. But before we begin our presentation, we would like to acknowledge the traditional owners of the unceded land on which we work, learn, and live, the Wurundjeri and the Boran peoples. We pay respect to elders past and the present, and acknowledge the importance of the indigenous knowledge in our community. So here's our team, and my role here is to designing the sorting algorithm for our forecasting project, which you will see a lot, and also coordinating between our team and also our manager, Roland. So before get starting to the main component, we're going to talk about the background information, and I'll pass it on to Neroline.
So first of all, there's many challenges with the current workflow that lab researchers are dealing with. They have bills to pay and multiple pots of money. So one of the challenges they might face is timing. So there might be some fund that can fund certain expenses, but it becomes expired before it can allocate itself to those expenses by its payment date. Another is having categorical restrictions. So there might be cases where some research grants can only fund equipment and travel, and some other grants can only fund salary. So as you can see, because of these restrictions, manually tracking all funding and expenses can be very time consuming and also troublesome. And that can limit how much we can keep track before we go into a spiral, which is 12 months at the moment. So the big question is, how do we maximize expenses paid while strictly adhering to time and category constraints? So let's walk through an example to understand the challenges we're dealing with. So here we have two funds. We have Fund A, which is worth $10,000, but it's restricted to salary costs only, whereas Fund B, it's worth $5,000, but it offers more flexibility by covering both salary and travel expenses. And both funds in this case are valid for the whole of 2026. And the challenge arises when multiple expenses request funding simultaneously. So if expense A requires $5,000 for salary in May, and expense B requires $5,000 for travel in August, a specific sequence of allocation is required to ensure both are paid. Ideally, Fund A should cover expense A to save Fund B for the travel costs, so both expenses are covered. But if we have an accidental misallocation, for example, by using Fund B to cover expense A, this can leave expense B unfunded because Fund A it cannot cover travel expenses. Now, imagine if we have 10 or 20 times the scale. Managing and forming combination of allocation would cause a headache. So this is why our team built a tool to lessen the work and the time for budget allocation using mathematical optimization. And next, Khan will introduce the technology we use for our project.
So we've built a forecasting budget tools as an R Shiny applications to automate this complexity. So firstly, at its core, we use BS package as it is primary package for our Shiny application to work with custom HTML and CSS theme. For the table visualization, we use a package called ET, and it is native to our Shiny and has many functionality that prove to be useful. One of which is using an outside library to manipulate the data table. To model the big questions, we use the OMPR package with MIP modeling, in opposed to the popular commercial Gurobi package. This is because of OMPR is freely available for everyone, unlike Gurobi, which costs money to use. For the solver, we use HISE. You can think of it as a very smart calculator that finds the best way to use a limited resource, such as money, time, capacity, while following the rules that you give it. And for the visualization, we use CoreDIAX. It is an interactive by default, and it's really easy to use for presentation when the data is small. But as the data grows, the performance might degrade, which is a point that can be improved in the future. Other than these main 6 packages, we use some other to read and write Excel file, and also for other small functions as well. The main reason for us to choose RShiny as a developing tools is that we already have a hosting an internal RShiny server, which should allow for an easy deployment into the existing infrastructure. Moving on, we will be talking about the overview, which I'll pass on to Minghui.
Next, I would like to introduce the workflow of our software. Our workflow is divided into 4 main steps: ingestion, partitioning, optimization, and output. And now I will explain these steps one by one. The first one is ingestion. This is the entry point where the users input their data, and we provide 2 options here. First, users can upload an Excel file that contains all the necessary information. And second, users can manually add data, entering funding and expense items one by one. And the next step is partitioning. In this step, we process the data that users has just entered. And firstly, funds are not processed. They simply move to the next step directly. And second, for expenses, we perform a sorting operation. We offer 3 ways to sort expenses. The first is by setting sorting rules. The second is by manually dragging and dropping expenses to determine the priority. And the third one is to use the default input order. And after sorting, the data moves on to the next step. Step 3 is optimization. This is where our allocation algorithm comes into play. The algorithm receives the funds and sorted expenses from step 2, and then calculates the allocation results. Users can trigger this step by clicking the Generate Forecast button, and the backend performs the computation. We will introduce the details of the algorithm later. And next step is output. Here we display the final budget allocation results in 3 different forms. First, a shortfall bar chart, which shows the number of expenses with shortfalls and their amounts. And next, second, an allocation plot. And in this diagram, you can see that on the left-hand side, started with an E represents expenses. And on the right-hand side, started with FS represents funds. And the next light green bar indicates portion of an expense that is covered by funds in the previous allocation. And next, for the dark green bars indicate allocation for the current period. You can see it's April 2025 now. And next, orange bar show the portion of an expense that couldn't be fully funded. And next, gray bars represent the funds that were not fully allocated. And the third, next, is the summary tables, which allows user to see each individual expense and the funding item in detail. And the next, finally, users are able to download the allocation results and the funding summary by clicking the Download Budget Allocation button. And then next is our results. Okay. And the next one is our live demo, which will present our software in more detail.
So I'll be showing you the live demo for our app. So first of all, users have the option to download an empty template, which is this green button here. And they also have a fill template they can use for now. So I'll choose an already filled template. So once it's uploaded, you can see that it fills the expense section and the funding section. And now we want to forecast. So we go to forecast page. And users can set priorities to their expenses. So there's expenses for manual priority and also for column priority. And we also have one for default. So this one is the default. We have one for manual priority. So users can drag their expenses around based on what order they want, and they can save order so that it's saved into the system. And for the column priority, so this one, the users can choose any of the 2 columns that we look at. So we have payment date and categories. So they can pick any of these, and the system will automatically arrange it for them. But for now, we'll go to the default version and generate our forecast. So we click on generate forecast, and it will be directed to the dashboard page. So this is all of the outputs. So the first section is our graph section. So we have the shortfall graph, we have the allocation graph, and lastly, we have all of the tables. So we have the budget allocation table, we have the unallocated expenses table, and unallocated funding table. But most importantly, users want to look at the visual outputs. So we have our shortfall graph here, which is interactive. So users can click on any of these bars and show the allocation during that month. So for example, we click on April, then it shows allocation done that month. In this case, there is none. So let's do another one. So this, for example, the green bar shows, so this is an active allocation. The users can also click on any of these buttons here on the sidebars and look at the allocation that month as well. And finally, users has the option to download the budget allocation. So they can click on download here, and it will show in their download section. But I won't show that. So the last part is the exit session. So this one, users can click on exit session, and they will confirm exit session, which will reload the whole page, and everything will be emptied out. So this is our demo for today.
Okay, so now you've seen the demo video, and we can dig a bit more inside to understand why our algorithm is doing such allocation. So our allocation consists of a 2-stage process. So it will start with stage 1, which is the primary optimization. So in this phase, we implemented a mixed integer linear programming model and carefully designed the objective function of the algorithms to ensure it will always try to find the expense with higher priority. So if we want to find priority 3 and 4, we must find priority 1 and priority 2 first. But there is 2 exceptions to this program. So first is when the payment date for the expense is not fall within the funding period. So for example, if priority 1 required to pay on Monday, but the available fund is only for Wednesday to Friday, then obviously we can't fund it, so we'll skip to the next one. And the second case is when the expense cannot be fully funded. So if priority 1 requires $3,000, but we only have $2,000, then we can't do anything about it. So we'll move on to the next on the priority list. Before we look into the allocation performed in the demo video, we can first inspect the funding and the expense spreadsheets that we input. So here's the funding spreadsheet. You can see each fund can only fund expense within certain categories, and each fund has a fixed funding period. And then for the expense, they are ranked by their priority. Each of them has been assigned to a specific category and have a payment date. So here's the allocation results after stage 1 of the algorithms. So we'll see down the list. So priority 1's expense fall inside fund 8's funding period, which is from January to August. And fund A can be used for salary. So it forms a perfect match. So it will be good. And now we look at priority 2, which is Jack salary. But all the active funds are having a starting date after the payment date of that expense. And which means there's no eligible funding for that. So we can only skip it. And then similar logic kind of applied to the down the priority list for the expenses. Since in stage one, we only fund an expense item if we can fully fund it, right? This could potentially leave some money that's been unused. And this brings us to the stage two, or the residual optimization, which aims to optimize the leftover fund by allowing them to be partially funded by the expense item. So in this stage, there's two changes to the funding logic. So one is that now we allowed partial payment. So if an eligible expense cannot be fully covered by a fund, we will fund it anyway. Second is the temporal constraint is relaxed to introduce an overdue logic. So instead of requiring the payment date to fall inclusively within the funding start and also the end dates, the stage two constraint simply requires the payment date to be strictly before the fund's expiration dates. So if you need the money right now, but you don't have it, if in the future you have the money that can pay this category, you can do a back payment. So that's basically what this logic means. And now we can look at the difference after we execute stage two. So we're again working from highest priority to lowest priority. So at this stage, now priority 2 can be funded. It will consume $500 from Fund D and also the remaining from Fund E because they have an expiration date after the payment date of Jack's salary. And then we look at Fund 3 and also 5. So well, for 3, there's no funding available for travel, so we'll skip it again. And then similar for 5. And now we look at priority 7. So John's salary. So under stage 2, since now we accept the partial payment, so it will be funded partially by the remaining funding Fund E, as that's the only one available, and it will be partially funded at 70%, and similar for priority 8. And finally, we're going to talk about what we learned from this internship and our future roadmaps. So what I did in this internship is mainly to develop a sophisticated sorting algorithms that can solve the real industrial problem, like the one shown here. Well, what I took away from this experience is that now I can understand the framework of developing a working web allocation from scratch.
And as for me, what I did during the project is I worked on the web app front end and also implemented the interactive visual outputs. As for what I learned is that it's important to ask a lot of questions during the length of the whole project, because the more you ask, the more you know.
Yeah, as for me, what I did is designing the UI and develop the backends for the applications. What I've learned from this is a better understanding of Git and GitHub workflow in collaborations. And I think the most important thing is what and how to ask questions to better understand the requirement needed.
Hi, so as for me, I mainly worked on the manual allocation of sample data sets using the allocation logic developed by the team. And I also contributed to the backend development for the application. What I mainly learned is that I learned a lot about Git and gained hands-on exposure to GitHub workflows. And I also observed the end-to-end process of building an app. And I also learned the importance of asking questions and seeking clarity, regardless of how minor a doubt may seem.
And for me, what I did, I helped design the system workflow and the structure of the input data. And I also developed the drag and drop ranking feature. And what I learned the importance of confirming requirements, and I gained experience in building a software from start to finish.
Okay, hi everyone.
We can then the remaining. I think we can talk about our future identity.
You could go to the. Okay, fine. We could start from here. So this slide mainly outlines the possible next phase of development for the project, focusing on making the system more flexible and more intuitive. So first, on the logic side, we could introduce flexible category-specific payment dates, We also thought to implement configurable expiration rules for back pay eligibility, for example, allowing a 7-day or 180-day window depending on the policy. This reduces rigidity and makes the model more realistic. And next would be improving how funding flows are visualized. Maybe plan to integrate Sankey or river diagrams to clearly show how funding moves from sources to expense categories. This makes the financial flows easier to interpret at a glance. And from a user perspective, adding flexible time frame views instead of grouping everything strictly by calendar month, and also introduce one-click PDF exports for finalized departmental reports. This improves usability. And finally, we can focus on strengthening system security through strict session timeouts and improve data sanitization protocols. So overall, this roadmap moves the system from like a functional to scalable, improving flexibility, interpretability, user experience, and security. So these are just yeah.
Yeah, and here's the resources and some documentation. You can feel free to scan the QR code to look them in detail. And finally, thanks for watching, and we would like to especially thanks our supervisor Roland and also the genomics invoicing team for much insights that they provided.
Really well done. It's really clear that you all collaborated really well. It's very rare that a project has a working output in the end of the first project. And I think that's also thanks to genomics invoicing team helping out as well. It was really, really well done. Very, very impressive. Thank you so much for being a part of it.